And I have the privilege to welcome Tiffany Callahan from SandboxAQ to the show. My name is David Giberman. It's a beautiful hot afternoon here in Tel Aviv. The summer has not given up yet. Tiffany, where are you calling in from?
Calling in from Boulder, Colorado today.
Oh, Boulder, Colorado. Oh, one of my favorite places in the world. I spent a summer there many years ago.
Oh,
Uh,
nice.
yeah. So, um, Tiffany, give us your official job title. I saw what it says on LinkedIn, but I'm not sure that's correct. So, how do people call you besides Dr. Tiffany Callahan?
Official job title is Senior Machine Learning Researcher.
Right. It says something on LinkedIn about AI agents and stuff like that. So
So since starting, I've definitely had played a few different roles internally and continue to, but officially it's just Senior Machine Learning Scientist.
well, that's I'm sure you have your work cut out for you with that. So we'll start the conversation with a I want to hear your the story of your journey, how you ended up at Sandbox IQ and how you decided to take this vector in your life.
Great question. I'd have to say my journey probably officially started during my PhD in computational biology, where my work was really focused on ways to use publicly available data as proxies of mechanisms of disease to try to improve subphenotyping in pediatric rare disease. And that during that time, I was really like kind of awoken to all the possibilities of how you could apply informatics at scale in health domains. And so wanting to take that further after my PhD, I did two postdocs, the first at Columbia University in the Department of Biomedical Informatics, where I worked on ways to try to make machine learning methods to do similar kinds of causal inference approaches on large scale claims databases, so hospital data again. And then taking a giant pivot, wanting to expand my skill set and try something new at IBM Research, I worked in accelerated materials discovery, where I really started developing new applied AI solutions like agentic systems, really focused around speeding up the design of novel materials. And
That's like totally different, right?
totally different. Totally different. And a good challenge. I have felt like I had developed some pretty good computational chops leading up to that and wanted to see, learn, expose myself to just a whole new area. And it was fun to see that a lot of the methods that I had learned and applied in more medical kinds of data settings were still very, very useful in the clinical, or sorry, in the chemical framework too. So that was also fun to see and apply things in that area as well. And I learned a ton.
That's cool. I bet you learned a lot. I mean,
So much. Chemistry is very hard. I think biology is also very hard, but the getting to work in between those two spaces was really exciting, and that actually is a good segue for what I'm doing at Sandbox, and I joined them really around that space and being able to have the freedom to try to build these intelligent systems that aren't just predictive, but ideally interpretable and mechanistically grounded, especially in the areas of drug discovery and more translational research applications. And when I say grounded, because I often get asked that question of, well, what do you mean grounded? So, like grounded in facts, grounded in data, so that when we're building these models and interpreting predictions from these models, we can feel confident that they're actually learning and telling us something interesting about what we thought they were when we built those models.
and that's right. And that's what I really loved about, what you're doing at Sandbox AQ, because many years ago, I was trained as a physicist, as a solid state physicist. And, since then I went off to do other things. But, I did capital market modeling and ETFs and all the way into cybersecurity for medical devices. And the last few
Oh,
years,
wow.
my company for clinical data management in the cloud. But when I saw what you're doing, I said, yes, it is so good because, the first thing you say as a physicist, you say, so what's the physical model, right?
Mhm.
People don't say, oh, let's predict the laws of motion with, I don't know, with
Text from the internet.
exactly with text mining or with BERT or something like that. People don't say that. And someone actually published a paper a year ago about about predicting EEG using large language models, and I said, but why? Um, the brain is always predicting. You probably know that, right? You know that the brain works on prediction all the time. So there's always like a large number of neurons firing, synapses firing for particular things. When you touch something or see something, it's not just one input; it's a bunch of inputs, and the brain is predicting who's going to be the winner. And the brain is always a few milliseconds ahead of the actual signal that they get from the synapses. So this guy published this article and said, look, I'm able to to predict predict things in EEGs using large language models. I said, come on, guys, you never heard of a straight line prediction, So, it's like people sometimes it gets out of hand, but I love it because a lot of companies in the space, some of the companies have been guests on the show, they're building statistical models by integrating large data sets for target identification, screening candidates, novel design, trial optimization, drug repurposing, and they're analyzing, bringing together genomic and multi-omic data, and they're doing all kinds of things. But we're looking back, as a person who was trained as a physicist, I said, where's the physical model? Okay.
Yeah.
And that's what I love about what you're doing. That is like so important in my, in my view. Okay.
Mine too. And thank you for pointing that out. That is another big reason why I'm here is wanting to, I sort of view it as the next level, tackling the hard problems, doing it the right way. And it's hard. It's very hard, but it's also super motivating just thinking that if you go down to the mechanistic level and you acknowledge and explicitly represent what we know to be true in physics and biophysics, then I think we stand a much better chance of not only building a realistic model, but avoiding some of these traditional issues of training your model on data that's just not really generalizable.
Right. Plus, you're training your model on data, which might be dubious also. So there's a lot of the things that people kind of tend to gloss over is the fact that the data, especially real world data in the drug world, is dirty, right? And there's a huge amount of effort that people put into to prepare and to clean and prepare the data for sure. But you have to kind of wonder. I mean, about that. I mean, the lead investor of one of my startups a few years ago said, you guys are working with KPMG, to get the financial reports every month. I don't want to get an Excel. I said I want it straight from the financial systems. Why? Because if it's an Excel, I know that somebody probably had their finger in the numbers, right? So you're
Yep.
preparing the numbers for me. So I don't want anybody to prepare numbers for me. And that's sort of the kind of thing I wonder about all the time because with all this data preparation going, you have to wonder how much of the data preparation involves cherry picking and massaging, this nice massaging of the data.
Oh yeah. No, that's a personal thing for me as well. In every paper, and I'm one person, so I try to do my part in switching the culture, but every paper I publish, we go from the raw data down to the data that went into the model, and that is provided as part of the paper. Because if you can't know exactly what we did and what we put into our model, then you really can't understand the value of the model because you got to know what you're starting with.
Exactly, exactly. So that's sort of I think a very big deal here. So um, I saw that there was an announcement on the website, something called SARE. Is that something you can talk about?
Yeah, so I was distally sort of involved in that effort from a collaborator perspective, but that project was going on before I joined Sandbox, and then I got very fortunate to be a part of it towards the end. So it's really around releasing this really valuable public resource, the biggest of its type, just actually added to Hugging Face yesterday, which is a big deal for us, wanting to actually make things we contribute back to the world for other people to use, which is awesome and very cool to be a part of. And that touches on a very similar kind of thing that my team is working on in that area too of biology, of how do we train these physics-based models that have first principle knowledge. Well, you need the data to do it. So this effort of actually like let's co-fold a bunch of molecules, look at these proteins with these molecules co-folded together. Let's have the actual ability to start training these pipelines that can do different kinds of drug discovery at different levels at scale. It's really exciting.
It's very exciting. And so I think it probably, for me at least, of all the guests I've had on the show, and we've had this, like, the show is on fire, by the way. I mean, I think I'm looking now, I'll tell you, we're up to 44 shows in 5 months. So it's like,
Wow.
it's really, really flying. And I have to say that you're the first company I've talked to, the first person I've talked to, the guest on the show who put their model on Hugging Face. Okay, which is, I think it's wild. I mean, it makes so much sense, but it's wild because people are so, it's not common, I think.
No, I'm really proud to be a part of a company that does that too. It's a different view of, okay, we're not worried about people scoping or scooping or taking what we're doing. We want to work with the larger community. So come see what we're doing and let's work together.
So for our listeners, people who watch the show, what are two good applications for SARE?
So that is a great question. I think I can tell you how we plan to use it, and then I know like a more general approach for how it's used. So it's definitely a vital resource for sure in drug discovery pipelines, specifically around wanting to develop new molecules within the protein space and wanting to have really fine-grained, precise information on how to do that and to do it at scale. So that's a general application. From another perspective, if we're thinking about, again, moving back towards those more mechanistically grounded models, being able to have a framework, let's say if we want to do some kind of in silico testing about what the impact of a new drug on a certain cell type is, if we have the ability to use something like SARE, then we could try multiple different molecules completely in silico, see where they're binding, what's happening inside the cell at the protein level, further distill that mechanistically into the regulatory aspects of the cell, and then get some kind of information at gene expression level. So answer questions like, what is the impact of this drug on human epithelial cells that are inflamed? Well, the impact would look like, hopefully, some kind of explanation that's transparent to describe the biology, and then also evidence in the form of, well, this is what's changing in the cell as gene expression is measured.
And you can get that out of SARE,
You get that out of a system that would use SARE.
the system that would use SARE, right? I can see it now. Yeah. Um, so who are your customers? Who pays SandboxAQ money to do this kind of thing?
So great question, and I will be totally transparent that I'm very heavily on the R&D side, but I can talk very generally in the kinds of domains that our customers were working with. So in in one form, we really work across a spectrum of a bunch of different kinds of companies who are trying to treat or prevent different health problems. So I know that's very broad, but what that looks like more in the domain is pharma, biotech, public sector institutions really working in the areas of drug discovery, toxicology, and precision medicine. So they'll range from teams trying to prioritize compounds and early stage pipelines to researchers who are really, really trying to make new therapeutics in areas like neurodegenerative disease or cancer. But increasingly, we're also seeing interest from groups who want to build data-driven regulatory or clinical decision tools. So I guess taking a step back, these are places that are looking for solid solutions, really trying to find ways to get more mechanistically grounded insight into the effect of different perturbations and the responsive biology to those.
Well, that was unexpected, actually, the regulatory part. Yeah, I mean, but I think, no, I suppose, yeah, why not? And the um, so the company was spun off from Google originally and raised a lot of money. So what are you doing with all that money? Excuse me for asking the question.
Great question. So if I hear you right, this is getting at the like what value are we creating with that all that money that we raised?
Yeah, exactly, exactly, right. So yeah, I had to ask the question. I couldn't resist.
No, I love that you asked that question. So, and then this is speaking purely from my perspective. So I believe our value is that we are developing the tools and resources to enable organizations to actually accurately model human biology in a way that's scalable, hopefully causal, and if we do that well, then fully explainable. So instead of just making tools that say things like, well, this drug changes gene X, what I think we're doing and what I'm really interested in helping us do and helping organizations that want to work with us do is to understand the why, the how, and in what context. And so this is crucial for predictability and safety. So my team is really working on developing tools and models that simulate how different systems, biological systems, respond to interventions, whether that's small molecule or a gene knockout, or maybe even a novel protein design using something like SARE. We want to take that to help design and do things like deliver agentic systems so that the people we're working with can have a nice packaged workflow that's easy to use and interact with and gives them a new way to interact with their data. So not just a here's an answer to your problem, here's a solution you asked for, but here it is packaged in something that you can actually like sink your teeth into, dig into, and learn more about your data and the resources that we're making with and for you in some circumstances. So long spiel short, I think the technology that we're working on, the value that we're bringing is really around making complex problems more feasible and ideally solutions that free up scientists' time to do more of their work and streamline their R&D processes.
Well, it's a tall order, and I love that you're taking it all the way from the sort of basic science to agentic AI systems. That basically you're shipping a, a system of Python code to a customer who can then run it, and they can go out and get good results using the system of agents that you developed for them.
Absolutely. Yeah, I think, and again, I can only really speak for myself, but I definitely think this is a general theme. It's not just about answering the problem and feeling really confident and providing a good solution, but also giving that answer and that solution in a form that people can actually work with, grow, adapt, and build from too. So it's a hopefully a reoccurring thing of continuing to work with people and learning from each other and advancing capabilities on both ends.
That's great. There's so much. And something I posted on yesterday on LinkedIn. I saw that you liked it. I just had this kind of insight was that there's so much talk now about how large language models can help with customer service. And I had something with the IRS last year, and you couldn't talk to you can't. It's hard to talk to real people, a real person now in the IRS. Okay, and so that I ended up with some AI system that was like talking to me. It was like actually I was thinking to myself, it's not half bad actually. It didn't actually have the answer to my question, but then again, but when I finally did talk to the human didn't have the answer to my question either. Uh, and the it was like, well, I couldn't kind of get that because the model was not trained on, it was only trained on stuff that the humans were trained on, and I guess that they wouldn't know the answer either, right? But customer service is a big thing right now in agentic AI, and in sales and stuff like that. But it occurred to me, and I suppose something I saw that you liked was that large language models can't do much for designing your next big product because they don't know the physics, they don't know the chemistry, they don't know the biology. Okay, and they have like a great representation of language, which what people were talking about these things, but they can't actually help you develop a new product, which will then make a shitload of money off of that product. Excuse my French. Okay, so that's I think where that must be hugely satisfying to see companies take your go beyond customer service, right? But and then give something that delivers something to biotechs who can actually create a brand new product.
Absolutely. Yeah, absolutely. I think just like you mentioned earlier, I think it's I think people are learning, if they didn't know already, that LLMs are not the end all be all to solve all problems, but we don't want to throw them out either. So having more of the large quantitative physics-based models that we're building, and then also using large language models to help make the user experience, the process, the orchestration of these more physics-grounded tools more fun or more explanatory is a good combination. But yeah, those alone are definitely not gonna cut it.
Yeah, exactly. So I like that. I did like what you were saying, using a language model to make it more fun because it can be really painful. People, our listeners should know, you see all this stuff. If you just listen to what's happening on social media, you would assume that everybody is already writing code using, I don't know, Lovable or something like that. And it's all just piece of cake. But I don't think people have any idea how much pain there is involved with developing real agentic AI systems, right?
Oh
How much,
yeah.
yeah, how much pain and systems engineering you really need to do to get it right. And the large language model is not going to help you too much there. So
No, no. Yeah, these systems are really fun. I think in some respects they harken back to traditional UX issues, but they're also really exposing how do you think about the things that you should be thinking about that you haven't thought about. So how do we know what to guardrail if we've never thought about making like unleashing these very powerful tools on systems that give people new capabilities that they've not had before? So how do we prevent people from doing bad things when we don't really know what those bad things will be? That I think that's a really open thing that the field will definitely have to figure out the best way to solve, balancing guardrailing without overly restricting or making these systems so slow that people are bored because it doesn't feel interactive anymore.
right.
That's an area I find really interesting.
Or there's too much autonomy and then the agent is just doing what he feels like or she feels like, right? So
Yeah.
um this is fascinating. We can probably talk about this all day, but so capturing value for I know you're not on the commercial side, but just sort of kind of like 40,000 feet. Is it like a project-based engagement with companies, or do they license? Well, they license solutions from you. How does it work?
So and again, I'll speak purely from my role in R&D. So it's really about finding ways to embed capabilities and different, more scientifically rigorously grounded systems into engines that people can use in their settings. So in some cases, the way that we're capturing value might mean partnering with our internal drug discovery team to help pilot new models that we build in real world pipelines with customers they're working with. In others, it might mean things like building tools directly that can integrate with things like foundation models, knowledge graphs, or even assay data that could be internal to us or could be provided by the customer. And so ultimately, I think the value capture from my perspective, and at least in my role, is really about making these complex, high dimensional biological problems more tractable without losing fidelity and hopefully as trustworthy as possible. So whether that's again partnering to help back our drug discovery team with new tools we develop, or just really thinking through how can we improve existing resources or add new knowledge or models to those pipelines.
Got it. Now, you just said something, you kind of like dropped a bomb on me there a second ago. You have your own internal drug discovery team?
Yes, yes, they're the primary interface with our external customers. So incredibly smart, talented people that are actually doing a lot of this pharma company has a question in these data, they need help making some new molecule. They're the ones who are actually at the forefront of that effort, and we're really just backing them up and supporting them in R&D.
Okay, I got it, right. So, but you're not a drug company yet.
No,
Not yet.
I don't know that I don't know what will become, but I can tell you we're definitely not right now.
I had a guest on the podcast, one of the early guests. They deal with prediction, and I said, what's your next step? And he said, well, we think we need to move, move upstream into maybe we'll become a drug company. I said, okay. And he's not the only one I heard say that, but uh, you have so much, I think, capability here. It seems to me you don't need to do that. Well, who's me to make that determination? So, so we're to the last question, which is kind of like an interview question. Remember when you were going to interviews, and people would say, "Well, Tiffany, where do you want to be in 5 years?" That typical interview question. But in this case, what are three things you want to do for your customers? And by the way, when I say your customers, it could be the internal drug discovery team inside SandboxAQ. So whether an internal customer or an external customer, what are three things you want to do for your customers in the next 12 to 18 months?
Great question. Okay, let's see. So first, I really would like to make causal reasoning a first-class citizen in life sciences, especially in AI. So too often, I think scientists are handed a black box prediction and we just ask them to trust it. I don't think that's okay. I want to change that. I want to design and build systems that don't just tell you what will happen, but they help you understand why it happens and tell you what will happen, and ideally gives you what levers you can pull to change that. So this shift really push people to shift from output to insight where realistic scientific acceleration lives. So let's make causal reasoning the center of AI in life sciences. That's one. Two, I really want to turn transparency into more of a superhero than a trade-off. So I'm done with this idea that interpretability means giving up performance. I want our tools to deliver state-of-the-art predictions and expose structure, confidence, uncertainty, and the context behind those, because I don't think trust should be optional when you're making decisions that might affect eventually downstream someone's life. And then finally, I want to build tools that scale with ambition. So whether our customers are just screening one compound or rethinking an entire disease program, I really would like to give them AI native infrastructure that scales technically and cognitively. So modularity, adaptability, and intuitive interfaces, but backed by serious, interpretable, transparent science. So moving from building models to really building systems that people can enjoy and think through and work with. Because let's be honest, I think science moves faster when software is trusted, transparent, and most importantly, fun. So you keep coming back for more.
Well, it's not just science; it's just business also. And
Yeah.
what's really I think fascinating is for me is that you know I I grew up in the tech world. I worked for Intel and I worked for some big Israeli tech companies and a defense contractor, and I did all kinds of things. And there was always this kind of like vision. View on life that you have B2C models and B2B models. So, you say if you're doing B2C, then there's also direct to consumer also. But it was either direct to consumer, B2C or B2B. But now what's happening now, I'm seeing what's happening now is that you have all these tech bio companies, and you're like a tech bio company, like a huge tech bio company. And a tech bio company is based on data and models, in your case, based on models that understand physics and chemistry. And you said it, you hit the nail on the head, in my opinion, which is that basically it's not just trust in the science, it's trust in the models, it's trust in what you're doing. And you really, people are beginning to get, I think, a little skeptical with all the hype. So I think for, maybe, drug company executives, they really are interested and really want to get into this, but they need to have the high level of trust in what you're doing. And that's something which we can't get overnight. In other words, it doesn't happen. It's not like, B2C, you're selling an iPhone, Tim Cook gets on stage and he introduces iPhone 16, and then the next day, they sell 500 million iPhone 16s or something. But it's much more much more complex than that. And because the data is complex, the models are complex, and if the data and the models are complex, then you need think about the things you were talking about, the guardrails, and build up that trust. Only after you build up the trust in the science and the models and the systems that you build, then what's happening is that then the customer will then come back and say, okay, now I'm ready to dance with you, right?
Absolutely. And I like what you said, and I think there's another element that we often leave out, which is we're so concentrated on trying to solve the problem right now that someone has in the best way possible, and that is very important. But I think another component of trust is they're also trusting you to deliver a solution that hopefully helps them move forward to the next thing that is good enough to scale forward in time. And so it's not just a one-off solution, but more like a system of resources that solve the problem today, but also help you figure out what problem to solve tomorrow.
Yes, absolutely. Because you don't know that question. You don't know the answer to that question right now.
No.
Do not. You do not. So great answers. I can see how deeply you're thinking about these things. It's been a pleasure having you on the show, and I could probably stay here talking to you for hours. But I think we've given a lot of food for thought to our listeners. Basically, we're nearing the end of the podcast. I'll explain how this works, and in another few weeks after we get past our backlog, and I'll write an essay on around the talk. I don't know what it'll be. I usually start thinking about it only a day or two before, and then basically the essay goes out on my newsletter, which I have a small but very active group of people in the tech bio world who actually read the newsletter. I was incredible. I had a newsletter last week. I think they had like 75% of the people read it, which is insanely high.
Yeah,
So
that's awesome.
that's what we're gonna do. So stay tuned, and I'm stay tuned to what you're doing at SandboxAQ.
Awesome. Thank you. And hopefully maybe in a year or at least sometime we should follow up again because I think I'll have much more specific things to talk about on some of what we're working with that would be fun to go over with you.
Let's absolutely do that. So let me just recap things. I've been hosting Tiffany Callahan from SandboxAQ. She's a machine learning
Research scientist.
research scientist at SandboxAQ. My name is Danny Lieberman. I'm the host of Life Sciences Today. We're part of the Healthcare IT Today network. We have a huge platform with over 100,000 listeners on Healthcare IT, and we're building up our readership on Life Sciences Today, but it's on fire. The podcast is available on all the podcast channels on YouTube and Spotify and Apple and Google and a bunch of others. And yeah, so that's it. Stay with me for a second after the podcast and after we finish recording.
Thank you so much. Pleasure to be here.
Thank you so much.